This is the third in a series of videos on sampling distributions. And in this one, what we want to talk about is we want to talk about properties of estimators. So the first thing we have to know is we have to know what we mean by what's the difference between an estimate and an estimator. An estimate is based on a single sample. And it is a number. Like an example would be, try to figure out how tall high school sophomores are. So let's get an estimate by taking a sample of 100 high school sophomores. That's based on a single sample and its number. So let's think what an estimator is. An estimator is a process. And what you get from an estimator is a distribution. And the key to an estimator is it assumes that you would take a repeated number of samples. Now, it's not important that you actually take the samples. It answers the question of what would happen if we did take repeated samples. That's what the difference between an estimate versus an estimator. Now, when we're talking about estimators, we talk about two things in particular. What we talk about is we talk about bias and we talk about variability. And let's talk about each in turn. So before we talk about bias, let's define some terms or some notation. And we're going to let mu be the true or the population value. And we're going to say mu hat is going to be our sample estimate. Or what's confusing about this is also the notation used for the estimator. Even though those are different concepts, we use the same notation for both of them. So let's talk about the definition of bias. We say the bias of the estimator beta hat is the difference between the expected value of beta hat and beta. So the difference between the expected value of the estimate and the true population value. So here's the key distinction. Bias is not whether or not you get the right answer. It's if you would take repeated samples, on average would you get the right answer? And that's the definition of bias. And we have some pretty commonsensical follow-up definitions. We say a positive bias. We say something has a positive bias if the expected value of beta hat is greater than beta. and we say something has a negative bias if the expected value of beta hat is less than beta. Another way to say a positive bias is this tends to overestimate, and this tends to underestimate. And that kind of makes sense. If on average you get a number that's too large, we say that it typically overestimates, and if we typically get a number that's too small, we say it typically underestimates. So what does variability mean then? Variability talks about how varied repeated estimates are, or how varied are estimates from different samples. And again, think about a distribution. Here are two different estimators, right, that have similar means, but this one, all the estimates would be clumped close to the mean, and here it would be much more spread out. And actually there's a fairly common drawing that talks about bias and variability, and they use the idea of archery. Or you can also think about the idea of darts. Think of a dart board or an archery board. And you're trying to hit the center. And let's say what happens is you get, when you shoot this archery, there are your hits. And if you notice, if this is the bullseye I want you to hit, I tend to hit in this direction, the northeast direction. So this would be a case where you have a biased aim. In this case, you don't ever actually hit the target, or rarely do you hit the target straight on, but many times you get close to it. And the question is, on average, are you close to it or are you far away? Let's look at two more examples. I apologize for the lack of artistry here. And let's look at one case where you hit here. Here you hit here. Now, in both of these cases, they seem unbiased. Maybe there's a little bit of bias, but roughly unbiased. But if you notice here, even though on average I tend to hit the bullseye, it's spread out quite a bit. So this has high variability or high variance. And this has low variance. And one way to make sure we can think through that is think about both of these together. Here's the bullseye. And here's another bullseye. Here's another bullseye. Right? So let's do one that is biased but low variance.